In circle O, segment AB is a diameter that bisects chord segment CD at point Z. Radii are drawn in as segments CO and DO. Jamila writes a two-column proof to show that the two chords are perpendicular. Segment AB and segment is perpendicular to segment CD, but she is missing a few steps. Read her proof carefully and then follow the directions. Okay, so she is proving that the chords are perpendicular. She's proving that AB right here meets CD at a 90-degree angle. So now we are seeing that blank 1 is a reason following the statement that triangle COZ is congruent to triangle DOZ. That doesn't really give me a lot to go off of, so this is what I'm going to do. I'm going to go over the previous statements back up to the given section. So they say segment CZ is congruent to segment DZ. So this segment is congruent to this segment. Definition of bisect. Segment CO is congruent to segment DO. Segment CO is congruent to segment DO. And segment OZ is congruent to segment OZ. Reflexive property. So now that I have these three triangles marked, I'm noticing that I've marked all three sides and that the corresponding sides are marked as congruent or the same. So I'm leaning towards the side congruence because we have three sides marked congruently, respectively. So in this triangle, this side is congruent to this side. There's the first side. CO is congruent to DO. There's our second pair of congruent sides, and segment OZ is obviously congruent to itself because it's the same line. So blank 1, I'm looking for a side congruence postulate. Segment, I jump to blank 2, definition of supplementary angles. Okay, this is what I would do to answer this one. I would go to this previous statement and notice that it has angles CZO and angle DZO are supplementary. So that would mean that I would lean towards a statement that had angle CZO and DZO. And then what is the definition of supplementary angles? If I didn't know that, I would open up the key terms again and look for supplementary angles. A pair of angles who have a measure that have a sum of 180 degrees. So I would be looking for this angle and this angle being added together to equal 180 degrees. And that's how I used the previous statement and its key term. So for blank 2, I'm looking for CZO plus DZO. CZO plus DZO is equal to 180 degrees. Its sum adds up to 180 degrees. That is the definition of supplementary angles. So now I'm jumping to blank 3. Blank 3 is a reason. So I'm going to go to the statement before to see if I can follow what happened between these two statements. So in statement 12, I noticed that we have 2 times the measure of angle CZO is equal to 180 degrees. The next statement, we have the measure of angle CZO is equal to 90 degrees. I'm going to ask myself what is different between statement 12 and statement 13, and I'm going to notice that statement 12 had a 2 being multiplied to the angle, and it equaled 180 degrees, and now this one equals 90. Well, I'm thinking, what's the relationship between 180 degrees and 90? And that's, it was divided by 2. It's half of it. So blank 3, it was divided by 2, so I'm looking for the division property because we divided by 2. And that's how I would use the context clues within the proof to answer this proof.